Okay, good afternoon, class. So today, I gave you some homework yesterday, and that was on exercise 5 on page 14. Any issues there? Yes, number 4. Any problem? 4 and 6. Any other problems? 4 and 6. Okay, page 14. Exercise 5. I hope you're all doing the homework, no? Exercise 5, page 14. So we are told that the sixth, we are told that the sixth term of arithmetic series. So it's arithmetic, so I can only use arithmetic formula. Okay? The sixth term, so it's going to be T6 is 32. The sum of the first 9 terms. So what does that mean? S9 is equal to 2, 3. Okay, you all agree with that? Determine the first 3 terms and the nth term. So in other words, I need to calculate A and D. That's what I need. So the arithmetic is Tn is equal to A plus n minus 1D. Sn is equal to, do I have the last term? No. So I must use n over 2 into 2A plus n minus 1D. However, if they had told me to calculate the sum of the first 6 terms is 2, 3, 4, then I could have used the other formula. Not so? Because the 6th term would have been the last term for S6. Or they gave me T9 and they gave me S9. Then I can use the other formula. Why? Because then I have the last term, the value of the last term. Does it make sense? No. If they say the 6th term of the arithmetic series is 32 and the 6th term is 2, 3, 4, then I have the last term. Can you see it? I would have the last term. Okay?
So must both be 6.
It's either both must be 6 or both must be 9 for me to use the other formula. Why? Because the other formula says Sn is equal to n over 2 into A plus L, which is the last term, which is the nth term. So if that is 6, then this has to be 6. If this is 12, that has to be 12 and so on. Okay? Make sense? Alright. So T6 would be what? In terms of the general formula, A plus 5D is equal to 32. So A is equal to 32 minus 5D. In this equation, why am I going to simultaneous equations? 2 unknown. Can you see that, people? For S9, wherever I see an N, now I put a 9. Can you see that? So what would that now be? 9 over 2 into 2A plus 8D equals 2, 3, 4. Okay? What do I do now? Divide by 9 over 2 both sides. So divide by 9 over 2. So it will be 2a plus 8d equals 52. As you can see, 2 is a common factor. I can divide throughout by 2, not so? So it's then going to be a plus 4d equals 26 in this equation. Okay. What do I do now? I'm going to substitute the EYC and A. Substitute equation 1 into equation 2. So what would that now be? Therefore, 32 minus 5d plus 4d equals 26. Okay? Take that over to one side. So negative 5d plus 4d. Negative d is equal to 26 minus 32. Negative 6. Is that correct? So d is 6. So now, to get a, I'm going to substitute that into that equation. Equation 1. Why into equation 1? Because we already have a as the subject of the formula. So a is equal to 32 minus 5 times 6. What is 5 times 6? 30. It gives you an a value of 2. Ever answer the question? No. So what is the first 3 terms? 2, 6, 2, 6 and? No, not 6. 8. I'm adding 6 to 2. You give me 8 and 14. These are the first 3 terms. To get the general term, Tn is equal to a plus n minus 1t. What's your a value? 2 plus n minus 1 times, I'm adding 6 all the time. Go and multiply that in, so it's going to be 6n minus 6 plus 2 is negative. Okay, who asked this question? Where did you go wrong? Well, yeah, you didn't divide by 2. But you should have gotten the same answer. Because if you don't divide that by 2, okay, then you're going to get, so you don't have this step here. But you got 2a plus 8 is equal to 52, no? Then you should have had 2a is 32 minus 5d plus 8d equals 52. Is that what you have, no? So you multiply out, read what you have there.
52 equals
Yes?
10d minus 60.
10. But if you multiply this out, I'm going to get 64 minus 10d plus 8d equals 52. So that is negative 2d is equal to 52 minus 64. What's 52 minus 64? Negative 12. Which still gives me a d value of 6. So your mistake is within this calculation here. You don't have d to be 6, no? So your mistake is here. Here somewhere in your calculation. Alright. And then it was question 6. No? You know where your mistake is. Okay, so I don't need to do question 6. Okay, so this is number 6 on exercise 5 on page 14. So the fourth term of an arithmetic series is 11. So again, T4 is 11. And the sum of the first 12 terms is 222. So S12 is 222. Determine the first 3 terms and the nth term of the series. Okay, so again, Tn is equal to a plus n minus 1d. Sn is equal to n over 2 into. Which one of the two formulas are going to use? Sorry? You see your mistake. So I don't have to do this. Anybody else want me to continue? So everybody else got it right. Okay. Alright. Then we proved yesterday the sum of formula for geometric patterns. Not so? Okay. But we haven't used the formula yet, no? So now we're looking at the example 1 on page 15. So the question says, determine the sum of the first 7 terms in the geometric series. Who can remember the formula we proved yesterday? Sn is equal to A is, open brackets, R to the n minus 1 over R minus 1. And the other formula, or the formula can also be written as Sn is equal to A, open brackets, 1 minus R to the n over 1 minus R. Okay. The question says, determine the sum of the first 7 terms of the series. So what's my A value? 3. My R value? How do you calculate R? What is R? The common ratio. How do you calculate the common ratio? T2 over T1 or T3 over T2. So what is 15 over 3? 5. So what's my R value? 5. What's my N value? 7. They want you to calculate the sum of 7 terms. So do that quickly. Alright, so this should simply be S7 equals 3 into R, which is 5 to the exponent, 7 minus 1 over 5 minus 1. With the calculator, don't keep yourself brave and do this calculation in your head, okay? The 3 open brackets, 5 to the exponent 7. Does that mean 5 58,593. You all okay with that? Any confusion? No? You look at example 2. Same page. Example 2, they say determine the sum of the terms in the series 5, 10, 20, 40. And then it carries on the till 655,360. So how are we going to do this sum? Well, how is this sum different to the previous one? We are given the last number. We are given the last term. The previous sum, we were told how many terms there were. Okay. What type of series is this? Arithmetic or geometric? What makes this geometric? There's a common ratio. So what's my common ratio value? My R value? 2. There was 10 over 5, or 20 over 10, or 40 over 20. My A value is 5. So to determine the sum of the series, since it's geometric, we can only use geometric formulae. Sn is equal to A or n minus 1 over r minus 1. Not so. We have A, we have R. Do we have n? No. So how are we going to calculate n here? Are you going to calculate n? Anybody? Yes, Michael. Okay, good. So he says you must calculate the general term of the series. You set it equal to the last term, and then you'll solve for n that way. Once you have n, we then substitute n into that Sn formula. Okay, so I'll give you a couple of minutes to do that quickly. I'll pause the video at this point. Okay, you guys finish? Alright, so for the general term, it will simply be Tn is equal to AR n minus 1. Why? Because it's geometric. Your A value is 5, your R value is 2, n minus 1. But we're saying the nth term is 655,360. So 655,360. So what's the first thing we need to do? Divide by 5 both sides. So we got 2 to the n minus 1 is equal to 2 to the n minus 1 is equal to what? Sorry? 131,072. You all agree with that? Okay, so 131,072 can be written as 2 to what exponent?
17.
So it's 2 to the 17. Remember, when bases are the same, exponents are equal. If you didn't know how we get that, you put it in the calculator. Let's fix this calculator quickly. We say 131,072 equals, you press shift and this button here. Okay, so we just press shift, just press it once, then it's going to be 2 to the 70. Okay, as you can see in yellow, is a factorized key. To activate any yellow key on the calculator, you first press shift. Okay. So it's 2 to the 17. So therefore, n minus 1 is equal to 17. So n is equal to 18. So what does that mean to say? There are 18 terms in the sequence. Not so. So now we use that formula. Sn is equal to a into r to the n minus 1 over r minus 1. So in other words, we're calculating 8 for 18 terms. So S18 is equal to A, which is 5, R is 2 to the 18 minus 1 over 2 minus 1. So that now gives us 5 open brackets 2 to the exponent 18 minus 1 over 2 minus 1. Gives us 1,310,715. You all agree with that? Is there any confusion? Nothing. Alright. Now we're looking at example 3 on page 16. Example 3 on page 16. Example 3 on page 16. The first term of a geometric series is 16. So what can we conclude from there? Zoe, you okay? So the first term of geometric series is 16. So what can we say about that? What can we conclude? Sorry? T1, yes, which is also what? A. So you write A is 16 or T1 is 16. The sum of the second term and the third term is 12. The sum of the second term and the third term is 12. Didn't we do a sum like this already? Sorry? No, okay. The sum of the second and third term is 12. So what do I do here? T2 plus T3 is 12. Determine the sum of the first 10 terms. So in order to calculate the sum of the first 10 terms, I need to know what A is, and I need to know what R is. Not so. I know what N is. N is going to be what? 10. Because they want to know the sum of the first 10 terms. Okay. So we start off by saying A is equal to 16. The sum of the second, so T2 plus T3 is going to be 12. So what would T2 be? Remember, Tn is equal to ARn minus 1. So what would this be? AR plus AR squared is equal to 12. But what is A? 16. So in other words, we can substitute A into that and we can calculate R. Not so? Once you have R, It might be that R is two values. Okay? Why? Because that's quadratic. Alright? Once you have R, you then determine the sum of the first 10 terms. Okay? I'm going to pause the video at this point. See any confusion? See any confusion? Yes, Michael? Okay, so we are told that the first term of the geometric series is 16. So it's T1 or A. Okay? Is 16. The sum of the second and third term, that's why I said T2 plus T3 is 12. Now remember for the general term of a geometric pattern is going to be AR to the exponent n minus 1. For T2 is going to be AR 2 minus 1, which is just AR. For T3 is going to be A times R to the 3 minus 1, which is 2. That's where we get AR squared from. At this point, we're then going to substitute. Wherever we see an A, we're going to put a 16. And then we have a quadratic, a trinomial that we can solve at this point. Okay. You can either use your quadratic formula or you can factorize using the rules of factorization. Okay. Okay, you guys done? So wherever we see an A, we're going to put the 16. So it's going to be 16R plus 16R squared equals 12. So it's 16R squared plus 16R minus 12 is equal to 0. R. So we can put a shift 5 or mode, sorry, 5 for equation, 3 for quadratic. So it's 16. 16 negative 12. Negative. Gives us, is that correct? No? So 16 is off. It's normally irrational values, that's why I knew it wasn't right. So we got two odd values, which means to say I can have two different sequences. Not so? Which satisfy that given introduction or the scenario given. So we say that if R is equal to half, if that is the case, then the sum, so what is the formula? Sn is equal to n over, no, not n over 2. Sn is equal to A Rn minus 1 over R minus 1. So what's my A value? 16. So I'm working out the sum of 10 terms. So S10 is equal to 16 into R, which is a half, 10 minus 1 over half minus 1. What does that give us? Check here. Okay. So we're going to get 16 a half the exponent 10 minus 1 over half minus 1. That gives us 1023 over 32. 1023 over 32. On the other hand, R is equal to negative 2 over 3. Then S10 now works out to be R, which is 16, sorry, A, which is 16, R is negative 3 over 2 raised to the exponent 10 minus 1 over negative 3 over 2 minus 1. That gives us an answer of negative 116 over
That's 11605
605
over 52.
over 32. Okay. Any confusion at this point? Yolan, yes, Michael.
So can you use the other one, so the other, which is 1 minus r, and you do that with this answer?
Yes,
Can you use that?
as I do it. For which one? This one here. Okay. So she's asking me to use the other formula, but for this one, so it's going to be S n is equal to A 1 minus r to the n over 1 minus r. So we got S10 is equal to A is 16 into 1 minus, open a bracket, negative 3 over 2 raised to the exponent 10 over negative 3 over 1 minus negative 3 over 2. The common made error, the learner doesn't put a bracket around this one here. And then they make the mistake in the calculation. Is that where you made your mistake? Yeah. So punch it in, you should get the same answer. One minus, open brackets, negative 3 over 2 raised to the exponent 10 over 1 minus 3 over 2. Same answer. Negative 11,605 over 32. Okay. Any other confusion at this point? You all understand? Alright. So for homework, I want you guys to do exercise 6, and that's on page 16. So now we're looking at the sum to infinity. The sum to infinity, or the sum of an infinite number of terms of a geometric series, can be determined if r is greater than negative 1 but less than 1. So let's, okay, so part of your homework you can read through page 16. The bottom of page 16, but I'll explain to you basically what's happening there. Okay. If you got, so they say the sum, the series will converge if r is greater than negative 1 but less than 1. That's basically what it's saying. Okay. Will converge. So what does converge mean? To converge, will be approaching a constant value. Not so. You see what they say it means? Converge. Yeah. Okay, so it would converge. Tn tends to 0 as n tends to infinity. Okay. So if you look at, well, if you take the formula Sn is equal to A into 1 minus, let's go with the other one, r to the n minus 1 over r minus 1. Looking at this formula, and I extract that part of the formula only. So I have r to the n. Okay, that's the thing. So let's choose a value for r. Let's choose a value for r, where r is greater than minus 1 but less than 1. Any value between that. Provided, of course, r is not equal to 0. No? Choose any value between negative 1 and 1. Oh, nice. Okay? So we're saying let r equal to r. Okay. We'll start tomorrow at this point. People enjoy the rest of your day. Good afternoon, class.